Hello engineers, welcome to Engineer Brandon's Tools. In this video, we're gonna build a temperature monitoring sensor with a PIC16F877A microcontroller. We're gonna build a temperature sensor in such a way that whenever the temperature goes beyond the threshold, the fan will go on to cool down the temperature. Then when the temperature goes below the threshold, the heater is gonna turn on in order to increase the temperature. So we're gonna use the schematic of the previous project, that's the temperature sensor project, and we're gonna use the code of the previous project. What we're gonna do is that we're gonna modify both the schematic and the code of the previous project. I'm gonna link the previous project at the end of this video so that you can be able to watch the previous project and understand more. So we're gonna use a 16:4 liquid crystal display. We're not gonna use 16:2 anymore. So we're gonna connect a fan and a heater to our microcontroller. To do so, we're gonna use a relay. So a relay is simply a device which is used when a smaller circuit is to control a larger circuit. So in this case, the microcontroller outputs 5 volts DC, and our heater is gonna require 220 volts. So the microcontroller can't do that, and our fan is gonna require 12 volts. So we're gonna use a relay to do this. So we're gonna take this one. So in order to connect with the relay, we're gonna need a transistor, a bipolar junction transistor. We're gonna need a diode. So for the fan, we're gonna use a DC motor. For the heater, we're gonna use a lamp. Then we're gonna require 220 volts for the heater, and we're gonna require 12 volts for the fan. So we're gonna connect them to our microcontroller. So I'm gonna change this to 1 kilo ohm. So I'm gonna connect the transistor. So the role of this transistor is preventing the microcontroller from being damaged by our relay circuit. I'm gonna need a diode. So whenever a relay is being switched on and off continuously, a back EMF is being produced. The role of this diode is to block that back EMF in order not for it to destroy our bipolar junction transistor. So we're gonna change this voltage, 220 volt AC. So this goes for the connection of the heater. So we're gonna connect it to this pin of our microcontroller. So the connection for the fan will simply be the same connection as this. So I'm gonna copy this. So we can notice that the nominal voltage for the fan is 12 volts. So after this, we're gonna add 5 volt supply to the relay. So we're gonna add 5 volt supply to the relay. So we're gonna write positive 5 volts. So we're gonna change this voltage to 5 volts since we're using a 5 volt DC power. So we're gonna write the code for this. So we're gonna use the code in which we use in coding the temperature sensor in the previous video. I'm gonna link the video after this video. So we're gonna modify the code. So we're gonna include the port C. We're gonna call port C1 as output and port C2 as output. So we're gonna define it here as C equals 0x00. It means all of port C as output. So that is a modification that we have done. So we're gonna say if the temperature less than 22 degrees, we should turn on the heater. So to turn on the heater, we're gonna write port C dot F0 equals 1. So this command means we should turn on the heater, and we should turn off the fan by simply saying port C dot F1 equals 0. So when the heater is on and the fan is off, we're gonna display this on our LCD. So we're gonna write command to display this on the LCD out. Since is a 16:4 liquid crystal display, we're gonna write heater on. And we're gonna write fan off. So we're gonna do this for when temperature between 22 degrees and 25 degrees, and we're gonna equally do it for when temperature greater than 25 degrees. So we're gonna copy this. So we're gonna paste it 2 times. So when temperature greater than 22 and temperature less than 25 we're gonna turn off both the fan and the heater. So we're gonna turn off the heater by sending a 0 here, and we're gonna say heater off. we're gonna turn off the fan, and here we're gonna display heater off. And so if temperature greater than 25, we're gonna turn off the heater and turn on the fan in order to cool the environment. So we're gonna turn off the heater and we're gonna turn on the fan by sending a 1 here. So we're gonna say fan on. Here we're gonna say heater off and fan on. So that is it for our code. So we're gonna run our code. So we're gonna load our code to our microcontroller. So the code is loaded. We're gonna change the frequency. So we notice that in the code we use an 8 megahertz frequency. So for the microcontroller we're gonna use 8 megahertz. So we're gonna run our simulation. So we notice that the temperature which is being read by the LM35 is lower than our threshold, which was 22 degrees. So our heater is being turned on. So if we add this temperature, if we increase this temperature between 22 and 25 degrees, let's say 23 degrees, we're gonna see that both the heater and the heater is gonna turn off and the fan is gonna remain off. So if we add the temperature beyond 25 degrees, we're gonna notice that the fan is going to turn on in order to cool down the temperature. So thank you for watching this video. Please don't forget to like, share, comment and subscribe, and we will be looking forward to more engineering tutorial videos. Thank you.